This is problem number 47 from chapter 5. In this figure below, this block of mass 5 kilograms is pulled along a horizontal frictionless floor by a cord that exerts a force of magnitude 12 newtons at this angle of 25 degrees. So I'm going to write that really quick right here so that we know that we have that information. So part A, what's the magnitude of the block's acceleration? So whenever we're doing a problem with blocks and with forces at angles, I think it's really imperative to draw a free body diagram. But when I do that, I am going to be drawing my force components. So the X component of this force and the Y component of this force, just so that we can get everything in the directions that we care about. So of course I have my force normal and my weight. But then from this force right here, we have force X and then force Y. And this is not necessarily to scale, but this gives us an idea of what forces we have going on here. So if I'm under the block's acceleration, what I need to recognize is that if we're being pulled along a horizontal frictionless floor, then the only force here that is going to be causing any sort of acceleration is force in the X direction, because I'm going to be accelerating in the X direction. I'm not crashing through the floor. I'm not being lifted up. So this is the only force in play here. So I'll have the sum of the forces in the X direction equals mass times acceleration in the X direction, which is indeed our entire acceleration, since we're only accelerating in the X direction. So we already knew that the magnitude of this is 12 and the angle here is 25. So I'm going to write out what we know. So Fx equals 12 times cosine of 25, because it's the angle, or sorry, it's the component right here close to the angle. And then Fy, of course, is going to be 12 times sine 25. And so from here, we can just use our Fx. So I have 12 cosine 25, make sure your calculator is, of course, in degrees, equals mass 5 times acceleration. And so we have everything we need to know. I can use my calculator and solve for my acceleration, which will be 2.18 meters per second squared. And we are done with part A. So next to part B. The force magnitude F is slowly increased. And I'm going to cross out 12 so we don't get confused. It's no longer 12. What is this value just before the block is lifted completely off the floor? Now keep in mind it says just before. So we are not off the floor yet, but we are about to be off the floor. And physics loves to deal with these kind of borderline cases. So we have the same free body diagram, but the thing that we want to consider here is that this force is getting bigger and bigger and bigger, meaning that Fx and Fy are getting bigger and bigger and bigger. And if I'm about to be lifted off the floor, then what that also means is that I no longer am being supported by the floor, meaning I do not have a normal force anymore. But let me draw out let me sum our forces really quick, just so you can kind of see how this works. So if I'm dealing with being lifted off the floor, then I want to be dealing with the Y direction. So I will have the sum of the forces in the Y direction equals mass times acceleration. And so I'll have up be my positive direction. So F normal plus Fy minus weight equals mass times acceleration in the Y direction. Now, if I'm about to be lifted off the floor, but I am not yet lifted off the floor, then that means that I have an acceleration of 0. And so this whole thing is going to equal to 0. But then again, like I just stated, if we're about to be lifted off the floor, then my floor is no longer supporting me. And so my normal force is also 0. And so we can see here that I will have Fy minus weight equals 0, meaning that Fy is going to be equaling to my weight. And so now I can go back here. Remember, our F is no longer 12, but I'm just going to use the variable F instead of a 12 there. So I will have F sine 25, because we're still at that same angle, equals our weight. And we know that our weight is mass times gravity. So that's 5 times 9.8. So my only unknown here is my F. So I can do 5 times 9.8 divided by sine 25. And we find out that our force with which we are pulling is 116 newtons. And so this is our diagonal force. We found that by just analyzing what was happening in the y direction because we were about to be lifted off. So lastly, we need to figure out what is the magnitude of the block's acceleration just before it's completely lifted off the floor. So that is dealing with the same exact situation. We still have our total force here of 116 newtons. And so then we're going to go back to what we did in the first situation. And so I will have the sum of the forces in the x direction equals mass times acceleration in the x. Because if I am not yet lifted off the floor, but I'm almost lifted off the floor, that still means that I'm only accelerating in the x direction. But now, instead of 12 cosine, my force is 116 instead of 12. So I'll have 116 times cosine of 25 equals my mass of 5 times that acceleration that we're looking for. And we find out that our acceleration now is 21.0 meters per second squared. So a couple quick tips here. Make sure that if you have a force at an angle, break it into components. And then, of course, make sure that when you have new information, get rid of your old things so you don't accidentally plug in your old pieces of information. And we're done.